Hello, everyone, and welcome to your channel Math Made Easy. Few sessions ago, we had gone over rotation of shapes, lines, or conic sections, or simply points in any by through any angle, clockwise or counterclockwise, not necessarily 90 degrees. Today, and because we are going to use rotation in part of the session, uh, we are going to go over reflection. Okay, today we are going to do a couple of easy examples, and then um, next time I will go over again rotating, say, a conic section around the line, inclined line. So we'll see how we do that. You see, in reflection, it's so easy if you are reflecting a point about the x or the y axis. If you are rotating about the x, you change the sign of the y coordinate. If you are reflecting over the y, you change the x coordinate. What if I tell you, for example, reflect a point, reflect P, which is, for example, 6 and 2, about the line y equals, let's make it a negative slope, negative 2x plus 5, something like that. So let's quickly try to see what's going on here. I have my x and y. Point 6 and 2, maybe something here. I have 0 and 5. So that would be 3 and negative 1, something like that. So reflect it over this line, or this axis. This is 6 and 2. Geometrically, if I want to do that, I will plot a line, a perpendicular line from the point to this line, measure it, and then extend it the same distance and say, okay, so maybe my reflected point is here, x and y. Yeah, you have to be very careful to draw the angle as 90 degrees and measure it to very cleverly and clearly. But that's how basically what we need to do. But what if I ask you to use math to find this point? How would you go about it? Notice, you know the equation of this line, and you know the slope of this line. So if I want to draw a line perpendicular to it, the slope of that line would be the negative reciprocal of that, 1/2, right? Negative 1 divided by the slope, which is negative 2. So you get 1/2. And if I know a point along this line, I can say y minus y1 equals the slope times x minus x1, which means my y equals 1/2 x minus 3 plus 2, so minus 1. That's the equation of this line. Then I would say, okay, these 2 points, their intersection is the solution. So if I say this equals negative 2x plus 5, it means I move the 2x here as 4x over 2, so that becomes 5/2 x. And when I move the negative 1 there as a positive 1, I get 6. And from here, I get x equals 12/5 or 2.4. Substituting back in this equation, for example, 12 times negative 2 is negative 24 over 5, and 5 is 25 over 5, so negative 24 plus 25 is 1, and y equals 1 over 5. That's the point of intersection. Notice 6 is 30 over 5, and 2 is 10 over 5. So the easiest, instead of using the midpoint equation, you can say, well, in the x going from here to here, the x dropped from 30. Forget about the 5 stays. But from 30 to 12, that's a decrease of 18. So if I subtract another 18, I get negative 6 over 5 as my x. The y was 10, dropped to 1. That meaning it dropped by 9. So if it drops another 9, it becomes negative 8 fifth. So the coordinates of this point, it's in the third quadrant, should be more here, down there. It's negative 6 fifth and negative 8 fifth. Okay? And that's it. Is there another way? Yes, we are going to introduce another way. This other way will require 5 steps. It seems too much, but you see why we need it next time. The first thing I'm going to do is to drop down 5 units. Why 5 units? Because if I drop 5 units, that's the y-intercept, this line would be passing through the origin, and you see why this is important. After that, I'm going to rotate it counterclockwise through an angle whose tangent is negative 2. Now, this point will be moving the same way. It will go down, and then you throw it, you turn it you rotate it. And then now this line would become the x-axis. So it's very easy to project over it. All what I need to do is to change the y coordinate. And then I rotate it again through the same angle after I reflect it. And then I raise it up 5 units because I brought it down 5 units. Very simple, right? It's like some kind of game we are playing. So the first step, this is negative 2 plus 5. So I have to subtract 5 to make it negative 2x, right? But if I subtract 5 from this, the 6, 2 becomes 6, negative 3. That's step number 1. Step number 2, I'm rotating counterclockwise through an angle. I don't need the angle in degrees or in radian. All what I know is that the slope here is 1. This is technically negative 2, but I don't care about the negative sign. I just need the 2, and that would be root 5. So this angle that I'm going to rotate counterclockwise through it has a cosine of 1 over root 5 and a sine of 2 over root 5. Forget about the negative because the negative will show up in the equations. Remember, rotating counterclockwise, we say the new x, which I call x prime, equals cosine of theta, which is 1 over root 5, times the x-axis, minus, when you rotate counterclockwise, you say minus 2 over root 5 times negative 3, which is the y. And the y prime would be 2 over root 5 times 6 plus 1 over root 5 times negative 3. Notice the negative is here. When we rotate clockwise, these two change, so that would be positive and that would be negative. So 6 plus 6 is 12 over root 5. And this is 12 minus 3 is 9 over root 5. Step number 3, I'm going to rotate about the x. So the y coordinate will change sign. So that point becomes 12 over root 5, negative 9 over root 5. Just change it. Step number 4, use the same equation, making this positive and this negative. And of course, instead of x and y, use x prime and y prime. So so x equals 1 over root 5 times 12 over root 5 plus 2 over root 5 times negative 9 over root 5. Okay? And the y becomes negative 2 over root 5 times 12 over root 5 plus 1 over root 5 times negative 9 over root 5. So that's the step before last. 12 minus 18 is negative 6 over 5. See, we already got that. Because we are not going to move the x, we are going to move the y, going to increase the y 5 units up because we decreased 5 units from the y in the beginning. Negative 24 minus 9 is negative 33 fifth. And finally, step number 5, the new y becomes negative 33 5, and we add our 5 units. Our 5 units are 25 over 5, and 33 minus 25 is 8, so that's negative 8 over 5. And finally, the point is negative 6 fifth, negative 8 fifth, which is exactly what we had here. And you say, but this is longer. Yes, it's longer, but you have to use it if you are trying, a more complicated, if you are reflecting a more complicated shape. Let's take another example and say reflect a line. So maybe I thought I had an example. Can't find it now. I had written down an example. It doesn't matter. So let's say reflect line, and let's make an equation y equals, let's say 3x plus 4 about another line, y equals 2x minus 6. Whatever. So here are the two lines. Here we are going to notice we are using some stuff we covered in rotation, and here I'm going to use something else. We also used in rotation, but its basis was the transforming of graph or transformation of graph. 3x plus 4, if this is 4, this line would be something like that. And I want to rotate this line or reflect this line over 2x minus 6. Here is negative 6, and 2x would be something like that. So the slope is less than that. So really, you can pick 2 points and do the same thing we did before. Find the new 2 points, and the line would be something like that. It's a lot of work. You see how we have to reflect one like that using, and then you create another equation and find another point of intersection and reflect. Or what we could do is to say, if I'm going to rotate about this line, first of all, I have to add 6 to this line to make it pass through the origin. And by the same token, this line also would move 6 units, right? And then I'm going to rotate clockwise through an angle whose slope is 2, reflect, rotate back counterclockwise, and then add the 6. So how are we going to do that? First of all, notice I want to add 6. And basically, if you remember how we did that, you can add 6 in and make it 3x plus 10. But basically, we work backward. We say, okay, if I want to move it 6 units up, I subtract 6. Remember, in the transforming of graphs, we say, what happened to this, to the y? I said, okay, the original equation was y equals x. So now the y, in order to return it back to be y, I have to add 6, meaning I move it up 6 units. So it has moved up 6 units, okay? Equals 3x plus 4. That's step number 1, which you can rewrite as y equals 3x plus 10. And many people would say, just add 6. Yeah, you're right. But I'm just doing it. I'm reminding you of what we did in graph transformation. Step number two, I'm going to rotate the equation, this equation, not the point. So whenever we say we are going to rotate clockwise, we apply the counterclockwise operation. Like here, we wanted to add, to move it up, we subtract it. If you want to enlarge it, you dilate it, you divide, and so on and so forth. You always do the opposite. So what we are going to do here is to say the new x prime, notice this, I'm rotating about this line, which has a slope of 2, meaning this is 1, this is 2, this is root 5. Same as before. I'm sorry, I picked 2. I should have done it the other way. That would be 1, 3, root 10. At least we use different roots, but I apologize. I was just making it up. I had an example, but I couldn't find it. I can't remember what it was. Okay, so it doesn't really matter. X prime now becomes cosine, which is still 1 over root 5 times times x, okay? And since I'm rotating counterclockwise, in fact, I'm rotating clockwise, but I'm going to use the equation of counterclockwise. And the y prime becomes 2 over root 5x plus 1 over root 5y. So I'm going to replace in this equation. The y becomes 2 over root 5x plus 1 over root 5y equals 3 times that. So it becomes 3 over root 5x minus 6 over root 5y plus 10. Excuse me. If you move things around, you get 7 over root 5y. And this becomes 1 over root 5x plus 10. You can multiply the y by -1, or you leave it and multiply everything by -1. It's the same thing, really. You can say you multiply the equation by -1. So it becomes that. That's step number 3. Step number 4, you are going to apply the opposite thing. So you say x prime equals 1 over root 5x plus 2 over root 5y. And the y prime becomes negative 2 over root 5x plus 1 over root 5y. So this guy becomes 7 over root 5 times the y, which is negative 2 over root 5x plus 1 over root 5y equals negative 1 over root 5 times 1 over root 5x plus 2 over root 5y minus 10. Now let's distribute that. You get negative 14/5 x plus 7/5 y equals negative 1/5 x minus 2/5 y minus 10. And then you are going to move down 6 units. So every y becomes y minus 6. And then you would say negative 14/5 x plus 7/5 y minus 42/5 equals negative 1/5 x minus 2/5 y plus 12/5 minus 10. If you want to write it, the y on one side and the x and constant on the other, you move the 2/5 here, it becomes 9/5 y equals. What about the x? I have negative 14. When it goes here, it becomes positive 14 minus 1 is 13/5 x. And then this becomes 42/5 plus 12/5 is 54/5 minus 55 is minus 4. Or minus 4/5, I'm sorry, minus 4/5. right? Because 42 plus 12 is 54 over 5 minus 10 over 5 is 4 over 5. You can multiply the equation by 5 and you get 9y equals 13x minus 4. Now, what we can say, um, do you know that the angle between these two lines should be the same as the angle between this line and the new line? Do you know how to find the angle between two lines? Of course, you can say, I know the slope of this, I know the slope of that, right? So you can do it this way. Meaning, this line has a slope of 2, so you can find the angle, which is arctan 2, arctan 2 minus, I'm sorry, arctan 3 minus arctan 2, right? This is the angle between these two lines. It's 8.13 degrees. Now, the slope of this is 13/9. So what is the arctan 2, which is this line, minus arctan, oops, I'm sorry, arctan, no, arctan 13/9, right? 8.13. It's the same angle. So at least we know that the projection seems to be correct. I cannot prove it's perfectly correct until I take another point. You can do a point like we did in the previous problem, project it over this line and see if it falls, if it satisfies this equation at the end. Maybe another, no, it's not going to be easy. Um, to find another proof quickly, but at least we prove that the angle between these two lines is the same as the angle between those two lines. I was going to stop here because really when we do that for a conic section, and because there are x squares or y squares or both, these equations will take really long time, and I didn't want this lecture to be very long, so I'm gonna stop here. But I promise you, I will prepare a nice problem for you next time to go over. Okay? Thanks and have a great day. Bye.